PPTC 121. Power Plant Steam Systems Session 11. Boiler Combustion Equipment and Auxiliary Equipment. The purpose of this session is to discuss pulverized coal operation and systems and burner control. The drawing is a cutaway of a power plant showing the major components. Agenda. Learn about water tube boilers and how they are supported. Learn about secondary air or combustion air. Define a continuous slag tapped furnace. Learn why pulverized coal is important. Understand how combustion takes place with pulverized coal, and what influences the pulverized coal process. Learn what the major features of a pulverized coal system are. Understand the 3 different designs of pulverizers. Learn what the requirements for a good pulverizer design are. Define contact mill, ball mill, and impact mill or hammer mill. Understand volumetric and gravimetric feeders and how they work. What are the 2 primary control requirements for combustion? How do coal burners efficiently work? Define 2-stage combustion and why it is important. Understand when lighters are needed. Learn about the requirements for a flame safety system. Understand the advantages and disadvantages of pulverized coal plant, and define what operating requirements are needed for a pulverized coal system. Importance of pulverized coal. Pulverized coal, PC, is the predominant method in use today on the large, highly efficient utility boilers that are used to provide the base-loaded electric capacity in utilities through the world. Pulverized coal firing uses a much smaller particle sizes, which allows for high combustion rates, and therefore, it is significantly different from the other coal combustion technologies. Boilers have at least 2 types of boiler air supply, primary air and secondary air. The primary air is the transport air used to move the coal to the furnace, and the secondary air is the combustion air provided to the fire. How combustion takes place with pulverized coal. The pulverization of coal exposes a large surface area to the action of oxygen and consequently accelerates the combustion. What influences the pulverized coal process? 1. Volatile matter in the coal is critical in maintaining flame stability and particle burnout. 2. Coal particle size and its porosity influences the rate of combustion. 3. The moisture content of the coal presents a burden to the combustion process. The moisture must be vaporized before combustion. And 4. Material matter or ash is inert material which dilutes the heating value fuel supplied to the furnace and must be extracted from the furnace in either bottom ash or fly ash. Continuous slag tapped furnace. Include Cyclone and some pulverized coal-fired furnaces that are operated at temperatures high enough to maintain ash in a liquid state until it is discharged from the furnace. These units are referred to as intermittent or continuous slag-tapped furnaces depending on the procedure used in removing then fluid ash removed from the furnace. What are the major features of a pulverized coal system? 1. The raw coal feeder takes the coal from the bunker and regulates the flow of coal into the pulverizer. 2. The air heater provides preheat to the primary air for coal drying. 3. The primary air fan provides transport or primary air to the pulverizer to move the pulverized coal from the pulverizer to the burners. 4. The pulverizer that crushes the coal to a specific size. 5. The piping that directs the air and coal from the pulverizer to the burners. And 6. The controls for operating the entire process. Here is a drawing of a pulverizer. There are many components to a pulverizer. You can see them here. Here is a typical pulverizer. There are 3 different designs of pulverizers. Pulverizers are used to grind coal into a very fine powder-like substance. The pulverizer types are 1. The roller type uses large steel balls between 2 ball races to grind the coal. 2. The ball mill type, that uses a large number of small steel balls to be lifted and dropped on the coal to grind the coal. And 3. The satellite type uses large steel rollers that roll on a table to grind the coal. Requirements for a good pulverizer design are: 1. Has optimal fineness for the design coal over the operating range. 2. Has rapid response to load changes. 3. Has safe operation over the load range. 4. Has reliable operation over its lifetime with low maintenance, particularly in the grinding elements. 5. Is capable of handling a variety of coals. 6. Has ease of maintenance. And 7. A minimum space requirement. Here is a cutaway of a contact mill or satellite type pulverizer. This is a ball mill pulverizer. This type of pulverizer has a very low maintenance cost, but is slow to responding to load changes. This is the ball mill process. These balls rotate around in the cage and break up the coal. This is an impact mill or hammer mill. It has internal hammers. Also, here is what it looks like from an external view. Hammer mills are not used to provide coal directly to the furnace. They can only crush coal to a 1/4 inch size, and as such are located in coal handling, providing sized coal to the bunkers. A volumetric feeder is one that delivers a specific volume of coal per revolution. The gravimetric feeder weighs the material on a length of belt between 2 fixed rollers located in the feeder body. The third roller, located midway in the span and supported at each end by precision load cells, supports half the weight of the span. As the material passes over the span, the load cell generates an electric signal directly proportional to the weight supported by the center roller. The microprocessor that samples of the amplified output of each load cell several times a second. This output is compared with the expected range. Each is converted into a signal equivalent to weight per unit of belt length. They are added to obtain a total weight per belt length. The microprocessor matches the feeder output to the demand by adjusting feeder speed. The idea is that every rotation of the head pulley delivers 100 pounds of coal to the furnace for combustion. Here is a cutaway drawing of a gravimetric feeder. There are two primary control requirements for combustion. The two primary controls for combustion are 1. Accurate measurement of the coal being burned, and 2. Accurate measurement of the air required to match that amount of coal. This gives the operator a precise fuel-to-air ratio prior to the O2 measurement at the economizer outlet. How coal burners efficiently work. The efficient utilization of pulverized coal depends upon to a large extent on the ability of the burners to produce the mixing of coal and air and to develop turbulence within the furnace. Emission requirements also dictate that efficient combustion take place with low NOx emissions. In order to reduce nitrogen oxide emissions, two-stage combustion is utilized. Two-stage combustion is when a portion of the combustion air is removed from the burner and introduced at another location in the furnace. This reduces the flame temperature by expanding the flame. Advantages and disadvantages of pulverized coal plant. Advantages. 1. Has changed rate of combustion quickly to meet varying loads. 2. Requires a low percentage of excess air. 3. Reduces or eliminates banking losses. 4. Maintenance can be done without cooling down the unit. 5. Can easily be adapted to automatic controls. 6. Can burn a wide variety of coals. 7. Increases thermal efficiency. And 8. Can produce high steam capacity. Disadvantages of pulverized coal are 1. Costly to install. 2. Requires skilled operators. 3. Requires multiple end burners to obtain satisfactory operating range. 4. Requires extra power to pulverize coal. And 5. Requires greater housekeeping to ensure a clean plant. Igniters are needed. A lighter is needed to initiate combustion in the following situations. 1. As pulverized coal is first introduced to the furnace. 2. As a burner is being shut down. And 3. As required for flame stability. Operating requirements are needed for a pulverized coal system. The air and coal feed rates must comply with load demand over the operating range. The unburned carbon loss should reduce efficiency by less than 1%. The burner should maintain performance without continual adjustment. Automatic flame safety and control systems must be used to ensure safe operation under all conditions. Here are the requirements for a flame safety system. Modern pulverized coal-fired boilers are equipped with a flame safety system. A scanner similar to that shown in Figure 5.32 is used at each burner to electronically monitor the flame conditions. Flame scanners evaluate the performance of the lighters and the burners continually. How our water tube boilers are supported. Boilers can be supported from the top or the bottom. However, larger water tube boilers are supported from the top. This is due to thermal expansion of the boiler metal due to heating. The bottom large utility boilers may drop as much as 11 or 12 inches from a cold condition to full load. This must be accounted for in the design of non-heated surfaces to avoid interference during plant operation.